In this presentation, we're going to look at area under the curve problems. So what we're going to do here first off is actually just describe the problem. Suppose we have a curve and a line, or otherwise two curves, and what we might be interested in is finding the area enclosed by those curves. So just a sort of rough sketch, suppose we have a line like this, just draw it down here, and a curve like this. What is the area? Now, let's just sort of assume that they do actually intersect each other, and we'll just go for a very simple posing of the problem now for the time being. What is the area between the two enclosed by the line and the curve? It could be in the other. It could be two curves as well. It won't be two lines though, because that doesn't make sense. Um, or no, it could actually make some sort of sense, depending on the way you pose the problem. If you have a third line there, like the y-axis or something like that, or the x-axis. But anyway, so compute the area bound by the curve. So we have to find the upper bound and the lower bound, a and b. So these are required. So we have to find, it's essentially the x-coordinate of the points of intersection of both lines. So we have to find out what they are. Essentially what we're doing is actually the integral itself is a definite integral of the difference written symbolically of, or mathematically, it's just as a single simplified expression of f of x minus g of x. Find the points of intersection. If you have a negative value, just disregard the sign. Essentially, the definite integral of g of x would have been greater than f of x, and your arbitrary choice of what should have been f of x and g of x, you probably would have been better off to reverse it. And remember to specify units. Now, in this case, square units various suffice, but just in an ongoing basis, just remember to specify units. I've done these two problems in separate presentations, so what I'm going to do here is go to a new problem. So let's just start off by saying that we have two quadratic expressions here. Both have the highest power is degree 2, so minus x squared and plus x squared. You notice though that the signs are different of the highest power. So we have plus x squared here and minus x squared there. That means we have two quadratics, but they have different orientation. One is upward facing, one was downward facing. It's sort of handy to know that on an ongoing basis. So let's just have a sort of quick look at what our curve should look like here. So it's the intersection of an upward facing quadratic expression and a downward facing quadratic expression, something like that. So the area we're looking for is something like this. Okay. Now it doesn't really, with regards to where the x-axis and y-axis are, it's not particularly important to know where they are. But what we are interested in now is finding out the a and b. So what we do here is find the points of intersection. So, or the x coordinate of the point of intersection, a and b. So how do we do that? We left f of x equals g of x. Okay. So x squared minus 4 equals 4 minus x squared. Sorry, just actually before I continue, this here is 4 minus x squared, this one here. And this curve down here is x squared. Sorry, that's the wrong way around. Whoops. This is x squared minus 4, the one that faces down. Whereas this one down here, the one with the negative component, shouldn't have done that, is this one down here. It's really hard to do that. I'll just sort of try a different approach here with my pens. This one down here, the upward facing curve, this is 4 minus x squared, that one there. So, I'm actually going to let this one equals g of x and let this one equals f of x. Okay. The reason for that is actually there's a sort of reason choice for that is because the area under g of x from a to b is this red area here, and it's less than the area under f of x, which is the red area, and the green area. Okay. So between a and b, that is. Now, so x squared minus 4 equals 4 minus x squared. Solving that, we get 2x squared equals 8. Okay, just add x squared to both sides and subtract 4 from both sides. Or add 4 to both sides. So x squared necessarily is equal to 4. Okay, so x is either plus 2 or minus 2. So this is actually minus 2 and 2. Now, obviously that means that the y-axis should actually go right down the middle there, but we'll forget about that for the time being. Okay, so what we're interested in now is, let's go back to our equation here that we're going to follow. This one here, for the integral from a to b of f of x minus g of x. There we go. So that is 2 and minus 2. F of x is 4 minus x squared. And minus g of x, that's x squared minus 4 dx. Okay. Let's simplify that. 2 to minus 2. That would be 8 minus 2x squared dx. Okay. Working that out, you will get, I'm going to just change the pen color, 8x, or change color as well, 8x minus 2x cubed over 3. This is just a straightforward definite integral problem. 2 to minus 2. Now that is equal to, it's a bit of calculator work here from now on. So just have your calculator ready and just remember to double check your answers. This is equal to 16 minus 16 over 3. Okay. Or you could have that as 48 minus over 3 minus, you could change 16 to 48 over 3. Actually, let's do that. That'd be a good idea. 48 over 3. Just to have everything over 3. And on the other side we have minus 16. And again, let's just change that to something over 3. So that's minus 48 over 3. Plus 16 over 3. Okay, so what we have here is 32 over 3 plus 32 over 3, and that is 64 over 3. I don't really have room to write it in there, but square units. 64 over 3 square units of area. Okay, so that's the answer to the first one. So let's have a look at the second one here. What we have here, find the area bound by the curve x squared minus 1 and the line 4x minus 1. So again, x and y axis. Okay. Y equals x squared minus 1, so that's downward facing. So that's y equals x squared minus 1. And we have the line here, let's just draw it like that. Y equals 4x minus 1. And what we're interested in is this area here. Okay, and again, what we do is we try and figure out what the upper and lower bound is. So A and B. Okay. Now, just to sort of emphasize that the area under y minus x squared minus 1 is this area here, the shaded area, or the area I'm going to put in little blue dots there. Whereas the area under between A and B, the area under y minus 4x minus 1 is this blue area plus the green area. So I'm going to make this f of x and g of x. Okay. If I was to do it the other way around, basically I get a negative answer. So, and it wouldn't really matter too much. All I have to do is actually just change the sign at the end. So it wouldn't matter too much if I got that wrong. So let's see now. Where is my solutions for this one? Let's just keep going. So find out the difference. Point of where is the a and b? Let f of x equals g of x. Okay. So x squared minus 1 equals 4x minus 1. So in that case we would have x squared minus 4x equals 0. X is equal to either x, well actually we factorize that first off, just go for a very simple factorization, and that is equal to x times x minus 4 equals 0. So x is either equal to 0 or x is equal to 4. So the lower bound here is 0, the upper bound here is 4. So integral from 4 to 0 of 4x minus 1 minus x squared minus 1 dx, that is equal to the integral, just keep going, of from 4 to 0 of 4x minus x squared dx. That is equal to 4x squared over 2 minus x cubed over 3. And what we have there now from 4 to 0. So 4x, so that is like 2x squared minus x cubed over 3. So from 4 to 0, or 0 to 4 even, so that is equal to 4 squared is 32. 4 squared is 16 times 2 is 32. 32 minus 4 cubed over 3 is 64. Alright, yeah, over 3. Minus 0 minus 0. Okay. 32 is 96 over 3. So what we have here is 32 over 3 minus 0. So it actually just ends up as 32 square units of area. So 32 over 3 square units of area. Alright, that's enough of that. That's 2 more questions done, so that's plenty of work done. So we'll leave it up there.